So question 1, find two values of side B in the example. So we're going to have to get something that's easy to read on the whiteboard here. So we've got white and we'll go for yellow. So we know that in that triangle there, we know that 8 over sine 31 equals 11 over sine C, and sine C will equal 11 times sine 31 all over 8, and therefore angle C will equal 45.09 degrees, or it could be the other one, 134.91 degrees. And if we look at our two solutions, solution 1 is going to be angle A equals 31 degrees, angle C equals 45.09 degrees, and angle B, that makes 76, 103.91 degrees. Solution 2 would be angle A equals 31 degrees again. Angle C is 134.91. Well, that adds up to 165. So this will be 14.09 degrees. So we do have two triangles. This is one triangle, A 31 degrees, 8, 11, and this angle up here is 103.91. That's side B. So therefore we're trying to find side B there, and we know that B over sine 103.91 equals 8 over sine 31, and if we work out B there, B will be 8 times sine 103.91 all over sine 31, which equals 15.08 degrees, length 15.08. And if we do the other triangle, we get a slightly different job. We get a triangle that's a bit more like that, 31, 8, 11. This angle up here is now 14.09 degrees. And again, we've got to find this side B. So we know that B over sine 14.09 equals 8 over sine 31, and B equals 8 times sine 14.09 all over sine 31, which equals, we get the answer 3.78. So there's our two answers, 3.78 for B and 15.08. Question 2, got to find angle FBG. If we look at the diagram, FBG is FBG, it's this angle in here. So there's your right triangle. We know that's 3. We've got to find this length across here, which by Pythagoras, we'll call it x. We know that 4 squared plus 5 squared equals x squared, so x squared equals root 40, x squared is 41, x equals root 41. So therefore, tan of angle FBG equals 3 over root 41, and FBG equals tan negative 1, that button, find the angle of 3 over root 41, which equals 25.1 degrees. So question 3, find angle A and A, B, C. And we know we've got sides 9, 4 and 11. So angle A is here. So we know that cos A, got to use the cosine rule, equals adjacent squared, 11 squared, plus the other adjacent squared, 9 squared, minus 4 squared, all over 2 times adjacent, adjacent. So that equals 121 plus 81 minus 16, all over 2 times 2, 99 times 2 is 198. So 121, 302 minus 16, sorry, 202 minus 16 is 186 over 198. Therefore, angle A equals cos negative 1 of 186 over 198, and angle A equals 20.05 degrees. Question 4, find x. Well, we haven't got x in the diagram, but we'll put x there. So we know that cos 121 equals adjacent squared plus adjacent squared minus the opposite squared over 2 times 7 times 4. So cos 121 equals 49 plus 16 minus x squared all over 120, it's over 56, excuse me. 7 times 4 is 28, and then times 2 is 56. So cross multiply, bring the 56 up, and 56 times cos 121 equals 65, because 49 plus 16 is 65. These two swap places, so x squared equals 65 minus 56 cos 121, and x squared therefore equals 93.84, and therefore when we take the square root, we get 9.69 as our answer. So there's the proof for question 5. One of the golden rules is to change everything to sine and cosine. So cosec, we said, was 1 over sine theta. Sec was 1 over cos theta. And whenever we divide by a fraction, we flip the one we're dividing by a multiplier. So it becomes times cos over 1. 1 over sine times cos over 1 equals cos over sine, which equals cot. Question 6. Got to prove it again. We've got sine squared times tan squared, and we've got to prove that that equals tan squared theta minus sine squared theta. Not easy, this one. Well, we know that this is 1 minus cos squared. Now, that may be something that's a bit alien to you, so let's just talk about that. We do know that sine squared theta plus cos squared theta equals 1. What happens if we now take the cos squared to the other side? Then we get sine squared theta equals 1 minus cos squared. And that is something else that we need to remember, a little variation. And that's exactly what we've got here. Sine squared theta equals 1 minus cos squared. Now we're going to multiply through by tan. So 1 times tan squared is tan squared. And cos squared times tan squared is just cos squared tan squared. Okay, well that tan squared stays the same. Now what about this tan squared? Doesn't that equal sine squared over cos squared? And here we can cancel these out, and we are indeed left with tan squared theta minus sine squared theta. Magic. So question 7. It says find sine theta if tan theta is 5/12 in quadrant 3. Well, we know quadrant 3 acts a little bit differently. There's your triangle. We've got, that's the angle. Tan is 5/12, opposite over adjacent, and they're both negative in quadrant 3. By Pythagoras, hypotenuse is 13. So therefore we're trying to find sine theta. Sine theta is going to be opposite over hypotenuse, negative 5/13. Question 8. Find two values of theta for which cos theta is negative 0.5813. So first of all we do theta equals cos negative 1, so we need to find the angle. We drop the negative 0.5813, and theta equals 54.46 degrees. And we know that cos is negative in quadrants 2 and 3. So here and here, and both of these angles equal a 54.16. 54.46. So in quadrant 2, we know that theta equals 180 minus 54.46, which is going to be 125.54. And in quadrant 3 here, theta equals 180 plus 54.46, which is 234.46 degrees. Question 9. Find 6 trig values. This should be fairly easy. The point negative 3, negative 4. Well, then negative 3, negative 4 is down here somewhere. That's the coordinate. So this is the x value, negative 3. Negative 4 is the y value. Pythagoras means that's 5. There's the angle we want. So it should be fairly straightforward now. Sine theta, negative 4/5. So therefore cosec will be the reciprocal, negative 5/4. Cos theta, adjacent, negative 3/5. So sec is the reciprocal, negative 5/3. And tan is opposite over adjacent, negative 4/3, which equals positive 4/3. And cot will be the reciprocal of that, 3/4. Just a little recap here of question 10. I've already done it for you, so I didn't put the record button on. But of course, you've got two values that have sine, the y value equal to √3/2, one there and one there on the unit circle. And this one here is 60 degrees, that answer, and this one here is 120 degrees.